All right, welcome to cybersecurity or information security, depending on which course you're taking. So what I want to do here is go through module one or chapter one that talks about the introduction to information security. As you can see, I'm using Whitman and Matt Todd's book on information security. So I encourage you to please buy the textbook or at least get the ebook version of the textbook. All right, so the objective of this module is basically for us to define information security, look at the history of security and how computer security evolved into information security, and then look at some key terms and critical principles in InfoSec, and of course, the roles of professionals within an organization. So we'll be looking at like a hierarchical chart. All right, so it says it doesn't matter the size of the organization, you have to make sure, or you have to be concerned about protecting your information, right? You hear the word that information is like the new oil. So whoever your stakeholders or interested parties are, you have a responsibility to protect that information, right? You always hear there's a scarcity of InfoSec professionals, but I always say either HR doesn't know what they're hiring, or the companies are looking for the moon, but they want to pay you pittance, right? Okay, so you should be trained in InfoSec. All right, so I started a long time ago in computers, or what is now called information technology or ICT in other parts of the world. But the point is that these whole issues about information security, the concern started after the first mainframe were developed. I had my experience with IBM mainframe and then VAX 11780 mini computers. So, but back then, the main threats that we were concerned about were physical threats to equipment, maybe some kind of espionage or sabotage, right? So this is really evolved. So this is the German Enigma machine. Some of you may have seen it if you look at the computer science history. So this was used during the World War for passing information. Of course, it was eventually cracked, and as a result, it wasn't effective. But when you get to cryptography, you look at the German Enigma machine. So in terms of information security, let's look at some key dates in here. I'm not going to go through all of them. I'm just going to talk about a few of them. So if you go way back to 1968, probably before most of my audience were born, right? Password security was talked about in terms of time-sharing computer systems. And you see stuff about the FIPS way back also back in 1982. You saw the first published version of what's called the Trusted Computer Security Documents, which came to be known as the Rainbow series. And then you got into the research on different things, like see the Unix research. So there's something called the Unix system or Unix operating system security. That particular report looked at how it looked at 4 things about how to handle computer security, right? It looks at the physical control of premises and the facilities, management commitment to the security objectives, education of the employees, which today we call end users, because we know that employees are the weakest link in security, and then also administrative procedures aimed at increase their security. So in the 60s, you see as the Cold War started, computer technology started moving, right? You now see what's called the Advanced Research Project Agency, start looking at what I call redundant network communication system. In security, when you hear the word redundant, it might mean like multiple. You hear it in conjunction with stuff like fault tolerance. You know, I mean, I need extra or something that is redundant, right? So later on, you will hear if you're doing like hardware, you hear about RAID, R-A-I-D, which is called redundant array of independent disk. But that's a normal term you start seeing in information security. So maybe if one fails, the other one can take over. So there's what's called the ARPANET. There are different theories on there. Like I just did another presentation on the history of the internet. and somebody will disagree with me. But in general, this is the conservative, maybe American view about the development of what we call the internet. But the ARPANET was the first project, right? So this would be like a document from the ARPANET, as you can see in this chart in here, right? So we now get to the 70s and the 80s. As ARPANET started growing, there was a concern about the potential misuse, right? All right. So what were some of the problems with, say, the ARPANET, right? So like individual remote sites, you don't have sufficient controls or safeguards. You have this about vulnerability of password structure or formats, lack of safety procedures, and then non-existent user identification and authorization. It would seem strange to you today where everything almost requires username and password, but this was part of the issues that we had way back then, right? So you see something also called the RAND report, RS-609. So it was basically a study about computer security and what the role of management and then policy issues involved. So we now started migrating or moving from just physical security concerns to stuff like how do we secure the data? How about access to our data? How do we prevent or limit random or unauthorized access to the data, right? And then how do we get different layers of management to be involved in InfoSec? So this is actually a very good chart. I'm going to try not to spend too much time on this, but let me explain in here. So if you open the motherboard of a computer, you will see what's called the CPU, right? The processor on the bottom. We can talk about that later on. But so here we're looking at the processor to the far left of my own screen. And then you now see I'm concerned about, okay, for a communication line, switching centers, maybe the hardware, you see coupling, system programmer, different things that have actual implications today, all the way down to the user level, right? Or remote console. This is what was seen in the RAND report, the RS-609 report. You can look at it. It's available on the internet, right? So early research on computer security looked at what's called Multics, right? It's interesting that the first operating system back then had security integrated into what we call the core functions. So as we now started having a time-sharing OS and other things moving from MIT, things started, evolving more in terms of InfoSec, right? You see some of the key players. And of course, as we're in that same time period, we now started having multiprocessors that were now increasing the capabilities and security threats. So later on, we'll talk more about Moore's Law. So in the 90s, now some of us were now mature in the computing sector. Internet was now more readily available, and it was called the first global network of networks, right? So, but still at this time, people were looking at security very kind of like low. They didn't see the significance. So you start hearing things like security was now being bolted afterwards as opposed to being integrated into the development of many systems, right? But even notwithstanding, you see that information security began to emerge as an independent discipline as opposed to being part of, if you're a programmer, if you were systems analyst, or at that time I was a programmer analyst for Pricewaterhouse. The profession of InfoSec was beginning to develop independently, right? So now from 2000 to the present, things obviously changed because what's called the threat landscape has now increased, right? So we needed to have more awareness of cybersecurity or information security. So what then is information security? In another slide deck, when I'm talking to some people, I talk about cybersecurity means securing the internet, which is kind of like very broad, right? So, but basically, the generic definition about security is such, again, using the word secure to define security, okay? So it's saying to you that it is the state of being secure and free from danger or harm, right? And what you take to make someone or something secure. So you have something called the CNSS gives their own definition of the protection of information and its critical element, including systems, hardware that use, store, and transmit that information. So there are many definitions, but for me, and as I'll tell clients or students, everything about information security or cybersecurity boils down to the CIA triad: confidentiality, integrity, and availability, right? Confidentiality meaning it's meant for the person that is only supposed to see it. Integrity means, can I trust that the information is what it's supposed to be, has not been messed with or tampered with. And of course, availability means it's available for the person that needs it when they need it, right? So this is a simple knowledge check question. What is security? I just finished talking about it, right? Okay, which is D, being secure and free from danger. That's the only complete answer in there. So it could not be freedom from fear, freedom from loss, or keeping secrets, right? So components of information security. So if you look on the bottom, you see the CIA triad we talked about, right? But if you look on the top, you also see something that called governance, right? Or management information security, and you see policies. It's almost like the old Roman buildings. Or if you're in DC, you see like how the, I think it's Lincoln Memorial looks something like this, right? So, but you also see computer security, data security, network security as being all components of information security. And then here's our CIA triad. So I always tell people, if you don't like the three-letter agency, you can switch it around. Call it AIC triad or IAC triad. But anyway, in the middle is data and services, right? Concepts that you should know as an introduction to cyber security or information security, what are called assets, attack, controls, exploits, exposure, loss, vulnerability, the threat agent, the threat event, and then the risk. These are things that you must know to have an understanding about information security. If I want to go through all that explanation, it will take a long time, but I always believe if you want to be involved in information security, you need to learn to find some answers yourself or research some things, right? All right, the critical characteristics of information, but even though I said that, I'm going to cover that if you're taking it as a 16-week class or 15 weeks class, by week number 12 or something, or chapter 12, I would have covered all of these definitions, so don't be worried, okay? But if you want to keep this chart, if you want to send me a message or email, or say, hey, you say you're going to cover this, and the course has ended and you've not really said it, but I can guarantee you we will cover all of this concept by the time we end. Not today, but further on, right? Right. So the critical characteristics of information, right? So when I'm trying to look at my information, I want to see, is it confidential? Is it integrity? Is it available? Is it accurate? What about authenticity? And then the utility, and of course the possession of that information, right? So see here, this is called the MC-COMBA cube, or MCOMBA cube, right? So it takes these things, the CIA we talked about, puts on the bottom storage, processing, transmission, and on the top you see the policy, education, and technology, right? So, and then you see the same graph. Besides the cube, you see the graph on there to help you understand the concept, right? So IS, information system, is obviously the entire hardware systems, data and network that enables the business to use information. So there's always a distinction between IS and IT, or if you're watching this from a foreign country, ICT, right? So, but all of this information here for the information system, they work together, right? To support you personally or your enterprise environment, right? Each one has its strengths and weaknesses, right? And of course, every one of them has security requirements or security implications, right? So the point about information security, you have to balance the security and the access to the information. Just like if you were a manager, you have to balance information security with the strategic business objectives. So that's what, like, if you're taking the CISM certification, it's expected that you can view security from a management perspective, because if you have too much security and it affects your business, then why are you in business, right? You have nothing to secure if you're no longer in business. So you can never have perfect security. So you balance protection and availability. If I make it so secure, people don't have access to it, right? So he always says to achieve the balance, the level of security must allow for a reasonable access while still protecting against the threat. Right? So there are some approaches to information security. Here what's called the bottom-up approach. So in other words, system administrator work to improve security of the system. The key advantage of going from the bottom to the up is technical expertise of the tech guys, right? But it says it doesn't really work very well, partly because of participant support and organizational staying power. I always say you got to go with the business on top. You got to be from not bottom up. You got to be from up to bottom approach. So this is the top-down approach, right? This is initiated by management. You see policies, procedures, and processes. So later on in advanced cybersecurity course, this will be called management controls or administrative controls, all right? So they have the goals. They look at accountability for each required action. So the most successful top-down approach will involve a formal strategy, which is referred to as the System Development Lifecycle, or SDLC. Sometimes that's confused with Software Development Lifecycle, but they're related. But here is System Development Lifecycle. That's the top-down approach because they understand the business needs, all right? So look at how this goes in here. So if I'm looking at the top-down approach, I'm starting all the way from the CEO and I go down all the way to the network or the security tech. Whereas if I'm doing bottom-up approach, it goes up there, right? There might be a debate as to which one works. Some people say, hey, maybe we should have a mixture of the two, right? So organization. So a wide range of professionals are required to support information security programs in any company, right? Of course, senior management support is the key component. It says is if management doesn't buy in, you're not going to get your money, right? You will not get the budget to implement your security. So additional administrative support and technical expertise are required to implement details of any information security program, right? So this is if you saw this chart in here, it's like a hierarchy chart, organizational chart. So here we talk about, but you still need to know what the roles of people in the organization as it relates to security, information security or cyber security. So our Chief Information Officer, CIO, not every organization have all of this, by the way. Some could be merged together. You are a Senior Tech Officer. So he's responsible for advising the senior management. Or again, you see the word strategic planning that affects the management of the information in the organization. And then you have the CISO, the Chief Information Security Officer. Many times they're the ones in the news now for like breaches. So this person is primarily responsible for assessing management and implementation of the information security in the organization, right? So usually this guy is under the CIO. If there's a CIO, sometimes the CIO might have the function of the CISO, or the CISO is just there, right? So here, this question is, the person who is responsible for the assessment, management, and implementation of the InfoSec. So you see that sec there, you know it's going to have to be CISO. All right, that's our answer B, right? So while in some organizations, CISO could report to the CFO, but it's not a very common situation, the Chief Financial Officer, right? All right, so this is our CISO place and their role in the organization. So on the bottom, you got your policy, risk, and then risk management technology, right? You got the CISO, and then on top of him, the CIO, and then the CEO on top. But you need a team, right? InfoSec project must need a team, right? So if you're looking at it from a project management perspective, so you need it's a small functional team who are experienced in one or multiple areas, require technical and non-technical expertise. So for me, since I was when I worked as a consultant to the U.S. government, I was also an IT project manager. So we went through a lot of these situations. You always need a champion, all right? And of course, you have your team leader, which will be some of us there, and then security policy developers, risk assessment specialists, your security professionals, system administrator, and of course, you have your end user. You need your end users, right? So all of these might be considered stakeholders. All right. So you heard the word data responsibility, especially now in the advent of like GDPR or the California Privacy Protection Act and other things. You need to understand these terms in here. So there are 4 terms on this screen. data owners, data custodian, data trustees, and data users. So the senior management that is responsible for the security, and use of a particular set of information is the owner of it. And then the custodian is the one responsible for the information and system that process, transmit, and store them. Even if some overlap or some are merged, you still need to know these technical definitions. And the trustees are appointed by the data owners to oversee the management of a particular set of information, right? And they coordinate with the data custodians on top for storage, protection, and use. And of course, the data users have access to the information, and they are thought an information security role because they're using information. So now, if you issue a subpoena for data, you need to know who gets the subpoena. For those who do not know the word subpoena, it means a court document saying, I need this information, right? All right, that would be a subpoena, or you hear the word subpoena, dusus tecum, as to bring that information on the person there. All right, knowledge check. Group of individuals appointed by data owners to oversee the management of a particular system, a set of information, and to coordinate with the data custodians for its storage, protection, and use. So let me tell you one clue about this question here. If you're taking an exam question, a certification exam question, and you don't know the answer, even though I prefer that my students don't guess, that you should read it and be able to understand the question, right? So when we look at Bloom's taxonomy, I don't look at just the bottom level of the rote level memorization. I'm expecting you to apply your knowledge, right? Especially since sometimes this course is taken by third or final year cybersecurity or computer science students or criminal justice students. All right, so if you look at this question in here, you see the word data owner. So that tells you that probably data owner is not the answer, right? Because it will be like almost like a tautology, right? Or doesn't make any sense. And you see the word data custodian. So that probably means it's not the first two. So this is a oversee the management of a particular set of information. So you're automatically thinking, you're probably not the data user, right? So that's going to be the trustee. Okay? Because somebody has appointed you, that makes you a trustee. All right, so just think that if I take a certification exam, read the question and eliminate some of those answers, right? All right. Communities of interest is a group of individuals united by similar interests, right? It could be the management professionals, the tech guys, right? That's what we call the communities of interest, right? All right, so it's information security. If I want to secure my assets, is it an art or is it a science? Always a debate, right? So people will tell you it's a combination of the two. That might be it's not a cop-out answer, but it says like security artisan, right? It's based on the way individuals perceive the system, and then the ability, that could be the art, right? Or secure as an art. There's no hard and fast rule, right? On many universally accepted complete solutions, no manner for implementing security through entire system. This one is kind of like dangerous. It's almost like a laissez-faire, anything goes kind of person. But as a science, technology is developed by the scientist and the engineer. You have specific conditions that cause virtually all actions in the computer system, right? Almost every security issue is a result of an interaction. So these guys these guys that would believe in what's called the cause and effect diagram, which is called the Ishikawa diagram, if you've ever seen it, or the bonefish. Something else causes this, right? But anyway, the best approach is probably to mix the two. All right, so that's what you need both. So what about security as a social science? All right, because I'm looking at the behavior of individuals interacting with the system. So it's maybe the security begins and ends with the people that interact with the system, either they do it intentionally or otherwise. So that would be looking at the information security as a social science, right? So in this situation, security administrators can greatly reduce the level of risk caused by end users and create more acceptable and supportable security profile. It's very good because we know that humans are the weakest link in any security policy, right? So, in fact, social engineers or those who engage in social engineering understand this aspect very well, right? Right. So, summary of this chapter, please. I expect you to do more research, read a little more. If you're one of my students at the university, you get a test that involves at least 3 chapters. But if you're just watching this video for free, hit me up with questions about the concept, even historical questions. Or if you have something to add, I love to since I've been doing this for a while. And every time I teach the course, I learn something new, or I learn something from the students. I was teaching for a while, doing some consulting in the Middle East, in a particular country, in a sensitive contract. But every time I go there, I learn something. And every time I teach university students, I learn something. Right? So when we're doing labs, somebody be like, "Have you ever heard of this lab?" Like one day somebody said, "Have you ever used a Medusa?" I'm like, "Medusa, as in Greek mythology, yeah, good for password cracking or different things." But the point is, please feel free to contribute. I'm one of those guys that I don't have a big ego, believe that I know everything in cybersecurity, because it is not possible to know everything. But of course, if I don't know something, we'll find the answers together, right? So in summary, we looked at security, meaning protecting our information from danger. We looked at the evolution of the information, right? So we're trying to protect our assets, whether we use, store, or transmit it, right? Through use of policy, education, and technology. And then I already said, when you think security, think the CIA triad, right? There could be multiple measures to do that. And then there are different components of information system, from the hardware, software, data, people, procedures, and of course, network, right? And then we said that the upper management drives the top-down approach, as opposed to the bottom-down approach that is based on the tech guys on the bottom, right? And we went over data owners, data custodians, data trustees, and data users. And I said, please know the definition and be able to spot them in a particular situation, right? And then finally, we ended with the question of, is information security an art or a science? And then we talked about it being also part of social sciences. And I mentioned the example of social engineers, right? So you can test yourself with this question. What is InfoSec? How has it changed over time? What are the characteristics that you should be aware of, right? And again, please feel free to send me questions, right? And I consider this the end of this chapter 1 module. I'm going to post this on YouTube, but also note that partly because sometimes on Canvas or LMS, we run out of space. When I post certain things on YouTube, because of copyright, they might flag it. So if they flag and they give me a warning, I'll find a way to make it private. But that, if it's private, that means you subscribe to the YouTube channel and then you send me an email, and I have to send you an email for you to be able to watch this video. All right? That makes sense? So have a great week, or have a great career in InfoSec cybersecurity.